Hey, this is Michael from Arc Smarter. In this episode of How to Dynamo, you're going to learn 10 ways you can use code blocks in your Dynamo scripts. Now, I'm a big fan of code blocks. They're super easy to create and they're really flexible. So whether you're new to Dynamo or you're a seasoned pro, code blocks can really elevate your workflows to the next level. Seriously. So let's jump right in and see what they can do. The first way we can use code blocks, and to be honest, the one that I use the most, is to use a code block to define values inside of my Dynamo script. Now, before we get to that though, the easiest way I can create a code block is I can just double click in some white space. And you'll see that's automatically going to pop up a code block. I can also go here in the library to script and choose editor. From editor, I can pick code block right here. But again, easiest way, I can just double click and there it is. And again, that's the biggest pluses in my book for using code blocks, is they're just so easy to create. Rather than sorting through the library here, you just double click and go. Now, with that in mind, when I need to create values for my script, a code block is a great choice. You can see here in this code block, I have 3 values set up. I have a numerical value here, 101. I can change that. That's an integer. I can make that a double or a decimal. I can just enter the number and that's all I need. Now, if I want to enter a string or a piece of text, I need to put that in quotes. So you can see I have quotes. This is a string, end quote. And you'll notice for all of these values, I have a semicolon at the end. And you'll notice through all of these examples that we look at, all of them have that semicolon at the end. And that tells the code block, hey, I'm done with this line. You can go on to the next line. Now, I can also, in addition to numbers and strings, I can enter a Boolean value. So I just type false and a semicolon. I could also enter true here as well. And you'll see that the code block color codes them differently. So numerical values will be in blue, string values are going to be in this orange color, and then Boolean values are here in yellow. Now, I find this so much easier to use a code block because I don't want to go to input. I don't want to hit basic. I don't want to choose, string or number or Boolean. I can just double click, use the code block, and then type my value. So it's really, really nice there. And if you're not using code blocks for this, I highly, highly recommend it. All right, our second use of code blocks is to do math. Now, again, I can go up to the, let's see, here it is. Here's the math library, and I can go to functions, and I can use functions here, or I can just use a code block. So I can do simple math, 10 plus 10, and nice and easy. If I click my watch node, you'll see I get the result 20. I can do kind of more complex math using order of operations. So I have 5 plus 5 times 10. That should give me a value of 100. And so I could build out, an equation as I need to with order of operations in there, rather than using multiple math nodes and operator nodes and so forth. So I can do multiplication, division, subtraction. I can also make use of math functions. So I can use the square root function, math.square root times math.pi. So if I go and look at any of the math nodes and I go to functions, let's say absolute value, you'll notice that the name of that node uses this dot notation, math.abs. Same thing, I can go down to math.square root. And if I look at, here we go, if we look at that node, there's that math.square root. So this is really helpful for us because this node name is actually using what's called the design script dot notation. Inside the code block, I'm making use of design script right here, which is Dynamo's kind of built-in coding language, separate from Python. So I'm not using Python here, I'm actually using design script. But fortunately for us, again, a lot of the node names use that notation. So if I want to use math.absolute to get the absolute value, I can just type math.absolute. So I'm going to do that right here, math.abs. And then let me try that again, abs. Oftentimes too, when I type it and hit the dot, it's going to give me a list of all the options that I have. And so I can just, rather than having to type, see if I can find it, here it is right here. Rather than having to type it, I can just select it from the list. So we'll get the absolute value of negative 100. I can plug that into our watch node and it's equal to 100. So that's a good tip as far as getting some of those function names. We can just look at the node names. All right, on to number 3. inside of my node, my code block, I can actually use inputs. So you'll notice in this code block here, I have first, second, and third as inputs. And the way I create that is I just type a piece of text, but I don't put it in quotes. So if I put it in quotes, the code block is going to recognize that as a string. If I don't use quotes, it's going to recognize that as an input. So now I have here first plus second divided by third. What I could do is create a code block, enter some numerical values. Let's say 10, I'll do 20 and 30. I'm putting those numerical values each on their own line. Now I can just plug them in to my code block here. You'll see as soon as I plug it in, it goes from red to blue. And now I have a numerical value of, or answer of 10.6. So I'm adding first plus second divided by third. So 10 plus 20 divided by 30. And that's my result right there. Now this doesn't work with just numbers. I can actually use this with text, and I can use it to what's called concatenate text, basically join text together. So in this code block, I have first string plus a hyphen plus second string. So I can put, let's say, I want to use A as my first string, and my second string, I'm going to do 101. So I can use those as my inputs. And my result is A-101. So I can use a code block in this way to concatenate all sorts of strings. And I could continue on. I'm not limited to the number of inputs I can use. And I can mix and match an input, like here, first string, with a kind of hard-coded text value, which is my hyphen right here. So I have a lot of flexibility in how I can join those. And I can use inputs kind of like I would if I was using a node. I can do them directly into my code block. All right, on to number 4. Within my code block, I can actually define a variable. So a little bit different from an input, but I can define a variable, and then I can use that variable later on in my code block. So here I'm setting first, a variable called first equal to 10, a variable called second equal to 20, and then I'm just adding first plus second. And so I get a result of 30. So I'm basically giving the variable a name, and then I'm setting its value. So I can mix and match this with inputs. So I have, again, first equal to 10, second equal to 20, and then the line below I'm saying first plus second plus third. So I can do a numerical value as my input. We'll take 50. I'm going to plug that into my third input. And so my result here is not what I wanted. It's telling me it's a null value. So let's see if we can, oh, there we go. Okay, I just had to hover over it some more. So then I'm getting 80. So that's correct. 10 plus 20 plus my input 50 equals 80. So I can mix and match kind of what I would call hard-coded values here with input values that are coming into that node. All right, number 5, I can also use conditional logic here. And I'm mixing and matching some inputs here. I could mix and match some variables as well. But what I'm going to do is create an if statement. And again, I can do this with regular nodes in Dynamo. In fact, if I go to script control flow, I have my if node right here. But sometimes, I'm feeling lazy. I don't want to go ahead and grab that node. Or maybe I want to build out some logic in a code block. So the way I do this, you can see here I have 2 inputs, var1, and I'm saying var1 greater than var2. Then I have a question mark, which is indicating that this is conditional logic. And then I have my result or value if true, and then my result or value if false. So I'm saying if var1 is greater than var2, output bigger, and if false, output smaller. So I have a code block with 2 values, 10 and 20. So if I plug them in, 10 is var1, 20 is var2. So my result here should be smaller. So 10 is not greater than 20. It's in fact smaller. And now I can also use an equal node. So I want to check if these 2 values are equal. So I can say var1 equal to var2. Again, I have my question mark to indicate it's conditional logic. And if that is true, then it is equal. If it is not true, it's not equal. So here I have 2 values, 10 and 20. and they are definitely not equal, so my result here should be not equal. If I change this up, I'm going to set 10 and 10, then it's going to show me that they are equal. Now, I'm using kind of string values as the return, but I could also set this to equal numerical values. I could have additional inputs here. So let's say we'll call this return 1 and then return 2. So those are going to become inputs. So I would need to input additional values. So let's say we'll put, this could be a string, this could be a text. So if it's true, we'll return, I could just use a true Boolean or a false Boolean like that. So those can be my inputs. And so this case, this should return a true value. So I'm not limited by what those inputs. Those could also be, specific Revit elements. I could use, whatever I want as those inputs. I just would need to pass them in as inputs, and then they will become the return values. All right, number 6. We're getting into ranges in sequences here. So I can use a code block to create a range of numbers and a range of letters. So the syntax I'm going to use is this ... syntax. So let me grab a watch node. We can take a look at that. Here we go. Okay, so I'm in this first example, I'm typing 0.1. So this is going to create a range of numbers from 0 to 1. And essentially it returns a list. The first number is 0, and then it goes all the way up to 10. So it's incrementing by 1. Now the second example here, I'm typing 0.100.5. So this third number here is my step value. So I'm going to create a range of numbers from 0 to 100, but I'm going to return every fifth number. So if we take a look at that, we'll see we start at 0, 5, 10, 15, 20, on and on and on till we get to 100. Now, if we compare these two lines, line 1 and 2, obviously in line 1, we're not including that step value. By default, when we create a range in a code block using DesignScript, the default step is 1. So we don't have to use that right here. But if I do want a specific range, I can, again, use that second part, that ... and specify what that step size is. Now, I could do this with letters as well. So here I'm saying create a range from A to Z. I'm not specifying a step value. So if we look at this, we end up with a list, should be 26 letters. So we go from 0 to 25. So that's 26 letters, and it's giving me the full range of the alphabet. Now, if I do specify that step value, I'm saying give me every fifth letter. Here we get, a lot fewer, A, F, K, P, U, Z. So we're getting every fifth letter in that range. Let me see here. I'm curious, if I type ZZ, will it give me, oh, no, it doesn't like that. So I was thinking if it could give me doubled up letters, A to Z and then A, A, B, B, C, C. But it doesn't look like we can do that. So we have to stick to our regular 26 letters. So in addition to creating ranges, here in number 7, what we can do is create a sequence. So the sequence syntax is very similar to what we would use for a range, except we're using the # to identify either the amount or kind of the number of divisions. So if we create this first code block, let me go ahead and grab that watch node, and we'll look at two different examples. I'm going to create a sequence of so we're going to start at 0. That's our start number here. We're going to create 20 numbers, and then we're going to step every 5. So our first number is 0, then we go 5, 10, 15, 20, on and on until we create 20 numbers. So we're not saying within a specific range of numbers like 0 to 100. We're saying I want 20, and then just give me those numbers. Same thing goes with using letters. So we're going to say our start letter is A. We are going to get 5 letters, and we're going to skip. Our step value is going to be every 2 letters. So now we have A, C, E, G, and I. So here is our count of numbers, 5, and then we're stepping every other number. If I were to get rid of that step value, this will give me, actually so it is looking for that step value. So I do need to include that. Whereas when I was creating a range, I didn't have to include that. So if I want letters 5 instances of a letter, I can do that using a sequence, but I just have to be explicit with what that step value is. Now, in this second example, we're going to look at this a little bit different. Instead of specifying what the amount is using the pound sign, we're going to specify what the division is here. So in this case, I'm saying give me a number from 0. So my kind of range is going to be 0 to 25. So here's my start number. Here's my end number. And I'm going to say give me 6 equal divisions. So if we take a look at that, let's move that guy over. Here we go. So you can see it's giving me 0, 5, 10, 15, 20, 25. So it's giving me 6 numbers from 0 to 25. Now, if I change this up, let's say I want to start this at 1 to 25, you'll see that number here is going to change. Likewise, if I say, give me 5 instances, it changes it up based on what those combinations are. So if you're looking for kind of equal spacing within a number range, this is a good option to use here. All right, for our 8th thing we can do with code blocks is we can actually create lists using a code block. So in this case, I have my code block right here, and I'm defining my list with a name. I'm calling it list 1. I'm setting it equal to, and then in square brackets, I'm identifying the elements in the list. So I have the letter A, and then I have a comma, the letter E, comma, letter F. And you'll notice I'm putting all of these strings or text pieces, text elements in quotes, and then I'm separating them each by a comma, and then I'm enclosing them all within the square brackets. So that's actually what's defining my list. I'm going to grab a watch node here, and we should be able to see our list getting output there. So there's my list, A, E, and F. Now I can do the same thing using numbers. I'm going to use the same syntax. I'm just going to not use quotes because I'm using numbers. So if I plug that into our list, here's our list of numbers, 22, 45, 78. Again, I could do that with whatever type of element I want. I could even use inputs, and I could put those inputs directly into a list. Now, once I have that list, I can get the item from the list by specifying the index number. So I have a variable here called item 1. I'm setting it equal to my list 1. And then in square brackets here, I'm specifying the index. So if we take a look at that, you'll see index 2 is going to return F. Now remember, items in a list start at 0. So A is at index 0, E is index 1, and F is index 2. So if I look at our other list, list 2, at index 0, I'm going to get number 22. Now I can also do a count of items in the list. So again, I'm going to use our design script dot notation. So I'm going to use list dot count, and then I'm going to count the items in list 2. So I should have 1, 2, 3, 4, 5 items in list 2. When I plug that in, there it is right there. And remember, I can always go to a node. So if I go to list inspect count, I can see here that the name of the node is list.count. So that tells me that's the design script syntax I want to use. And I just plug that in, list count, and then in parentheses, I put my input, which is the list. So I can use that node kind of as a cheat sheet. All right, we're on the home stretch. Let's go to number 9. And this is where things start to get really kind of interesting and fun. So I can use a code block to create Dynamo geometry. And I'm going to do that, again, by using that design script notation. So if we go to our geometry library, I'm going to go to points, point. We have our by coordinates node right here. So this is telling me point by coordinates. I can type that into my code block, and then in parentheses, I put my inputs. So I'm going to create a point at 10, 10, 0. And then I'm going to create another point here at 0, 10, 0. So I have my 2 points. Now I can plug them into a third code block that's using the line.byStartPoint endpoint node. So I can, just to confirm, I can go to curves, line. Here is my start point, endpoint node. I'm using that same syntax. Oops, got that guy in there. Let me see if I can, there we go. Let me delete it. Ah, no luck for me. All right, let's see. Third time's a charm. I'm gonna right click, delete. There we go. Okay, so here I can just plug in those points that I created in my code block. There's my start, there's my end, and I can see it created that line right here. Now I'm using this as a combination of 3 different code blocks. I could actually condense this into a single code block here. And by using some variables, I can refer to those variables in another line inside of my code block. So I'm creating a variable called point1. That's a point by coordinate at 0, 0, 0. Creating another variable called point2, and that's a point at 20, 20, 0. Then I can create a line that's using the line by start point, end point. So that's going to give us this line right here in our Dynamo preview. So if I change any of these values, let's say we want this to go 2030, you can see it's going to change that line. So within this code block, I've built up a series of variables and then ultimately creating the line that I want. And that's all from within one code block. Now our last kind of use of code blocks is that I can kind of take this to the next logical step and I can create Revit elements. So let's say I want to create a Revit wall. I can use the wall by curve and height node. So I'm going to go into Revit elements, wall, and just so we can verify with our design script, I'm going to go by curve and height. So here is the design script, and you'll notice though that I prefixed it with Revit here to say that I'm actually creating Revit elements. So Revit.wall.by curve and height. Now, some of these values I could hard code, and some of them I'm going to need inputs for. So I could create the curve like I did up above here. In fact, let's just copy this geometry for future use here. But I could also have an input as well. So in my parentheses, I'm just typing curve. That's the input I'm going to use. 20 is going to be the height. And then I'm going to have an input for level and wall type. So those I'm going to need, level and wall type, I'm certainly going to need inputs from, because I can't, by using design script, I can't specify or get the level or the wall type. But I'm going to use a levels node and a wall types node. And then for the curve, I can just come up here, use the curve that we created, and I can plug that in right there. And so if I do a split screen with Revit, I can see my wall right there. So if we were to change some values up above here, let's say we want to start, instead of 2030, we'll go to 4030, and then you'll see that that wall changes. So we're using the points we create above, we're adding that to create a line that's getting plugged in all through using our code blocks. And as I mentioned, I could also specify this if I want to, hard code my points in here and my line in here. I wouldn't have to use that curve as an input. I could just specify our line variable right up above. You'll see as soon as I do that, then it's going to adjust that accordingly. So my inputs change. So I just have a level and a wall type input because I'm generating all of that Dynamo geometry above, and I'm using that Dynamo geometry to actually create my wall. All right, so those are my 10 ways you can use code blocks in your script. Hopefully you picked up something new. Now, I would say, just as a little bit of a warning, I've seen some scripts that use some really extensive code blocks. And I would encourage you, not to get too carried away with the code blocks. I like to keep them between, 1 to 5 lines of code in here. Like this is actually pretty good because I'm not adding too much complexity. And if you start adding a lot of complexity, sometimes it can be difficult to troubleshoot inside here because I don't really know where things are falling apart. So it's good to kind of chunk your code into, 1 to 5 lines. That way it's easier to troubleshoot as you go. All right, so that's all from me. Hopefully you learned something, and I'll talk to you soon. Bye. Thanks for watching. I hope you enjoyed this episode of How to Dynamo. If you did, go ahead and click the subscribe button to get more Revit automation tutorials. Also, check out my free Dynamo template using the link over there. This template contains 20 node groups for common Dynamo actions, and it'll save you a ton of time when you're creating your scripts. Just copy and paste the groups you want, and you're on your way. All right, that's all from me. I hope to see you soon. Bye.